This is the most important topic. In case of algebra, that there were expansions, factorizations, and mostly quadratic. So related to chapter 2. Equations and inequalities. We had quadratic equations again related to chapter 2. Number 3, graphs and transformations. Again, mostly cubic quadratic, they were just sketches, and transformation related to 2. When you have the completing square form, value of h increases, the graph moves to left. H decreases, the graph moves to right. Value of k increases, graph moves up and down. When the coefficient of x square is positive, it is a smiley face. When the coefficient of x square is negative, it is a sad face. Again, related to quadratics. Chapter number 5, which we just did. If quadratics is involved, if the equation, like the simultaneous equation, is of the order 2 or more or less coordinate geometry. Chapter 6 again will have a strong link with chapter 2 in case of completing square form. Midpoint of perpendicular bisector related to chapter 5. Equation of circle is strongly related to completing square form. What we'll be doing is we will have two completing square forms in one equation. I'll show you something, and do remember that you have to revise 2.2. Chapter 2, exercise 2.2. You have to revise this completing square form for circles. So what are our objectives? Find the midpoint of the line segment. Straight away formula of midpoint and nothing else. Find the equation of perpendicular bisector to the line. Same as chapter 5. Perpendicular m1 into m2 equals -1. Bisector, we already have the midpoint from previous point. Know how to find the equation of circle. Now, how to find the equation of circle? Firstly, it is strongly related to completing square form, this form. If you can't recall, x plus p whole square plus q. Generally, it was h and k. Then solve the geometric problem, straight line and circles. Geometric problem, this is simultaneous equation. Then it says use circular properties to solve problems on coordinate grids. Again, a mixture of coordinate geometry and simultaneous equation. Last point is find the angle of in semicircle and solve the problem involving circles and triangles. A shape would be given and definitely we'll solve for the unknown. For example, you are given with this shape and you know the points of A and B. If I find the distance AB, I know the diameter. I subtract it by 2, divide it by 2, I get the radius. So now I have the radius and I have the midpoint. That means I have the coordinates of center of circle and radius. So when you have the center and radius, you can write the equation of circle. We'll do that at the end. Before that, we just need to have a strong grip on completing square form. Find the midpoint and line segment joining each pair of points. So can you do this? Midpoint, do you remember? What was the formula?
y2 minus y1 over x2 minus x1.
That is the gradient. So
the
x1,
midpoint,
y1 plus y2 over 2. This is your formula. So adding x1 to x2 is 10 by 2 and again 10 by 2, which is 5, 5. If we try this question, x1 plus x2 is 4, y1 plus y2 is 2. So your midpoint is 2, 1. Okay. So this exercise is related to midpoint. And why are we doing this midpoint? Questions like this would be needed to solve to get the center of the circle, to coordinates of center of circle. It says the line segment AB has the endpoints A and B. The midpoint is already given. Find the values of A and B. So if we solve this, x1 plus x2, which is x1 plus x2 by 2, comma, y1 plus y2 by 2. So I've done the midpoint of AB, and it is already given that midpoint of AB, x coordinate is 4. So I will equate this x coordinate with 4. Minus 2 plus a by 2 is equals to 4. Minus 2 plus a is equals to 8. So a is equals to 10. Solving for b, we already know that the midpoint, the y coordinate is 3. So 5 plus b by 2 is equals to 3. 2 3 times is 6. So b is equals to 1. A is 10 and b is 1. In the previous question, both points were given and we found the midpoint. In this question, points are missing and midpoint is given. Question number 4. The line segment RS is a diameter of the circle where R and S are these 2 points respectively. Find the coordinate of center. Diameter is already given. So we'll find the distance we'll find the midpoint straight away because endpoints are given of the circle. And this would be in terms of A and B. Question number 5. The line segment AB is a diameter of the circle. A is given, B is given respectively. Find the coordinates of center of circle. Show that the center lies on this. Okay, this is interesting. So AB is the diameter. Find the coordinates of center. For center, the center would lie at the midpoint of diameter. So x1 plus x2 over 2, comma y1 plus y2 over 2. So 3 minus x is 3 by 2. 10 minus 4 is 6 by 2. So 3 by 2 and 3. Coordinates are 3 by 2 and 3. Now we will check if this point lies on this. Y is equals to 2x. Y is 3. 2. X is 3 by 2. 3 is equals to 3. So left hand side is equal to right hand side. So shown that it lies on this line. Look at question number 7.
It always has to be left hand side equals right hand side, right?
Whenever we have to show yes.
Okay.
The line segment AB is the diameter. It says, coming back to your point, show that the center of the circle lies on the line. If it lies on the line, then yes, left hand side must be equal to right hand side.
Thank you.
Question 7. The line segment AB is the diameter of the circle. So we are given with A and B respectively. Show that the center lies on this line. So first we'll find the center. Center is the midpoint. So 0 plus 6 by 2 minus 2 plus 5 negative 5 by 2. So 6 by 2 is 3 and 7 by 2 is 3.5. So I have x and y and it says show that it lies on this line. So left side should be equal to right hand side. So x is 3 minus 2 into this is negative 3.5 minus 10 is equals to 0. So we have 3 minus 2 into minus 3.5 is positive 7. Minus 10 is equals to 0. 3 plus 7 is 10. 10 minus 10 equal to 0. 0 equals 0 shown. Is this thing clear?
Yes, sir.
Okay. The perpendicular bisector of the line segment. Perpendicular bisector, again, what we just did. If you have A, you have B, you can find the gradient, then find the midpoint, and then find the gradient of perpendicular line and the equation of line. So if we have AB, we can tell everything about this line L. Is there any confusion in this part? We have AB, we can find gradient M1. By using M1, we can find M2. And then using A, B, we can find the midpoint, which is C. So we have the point, we have the gradient. That means we can find the equation. Is this section clear?
So could you just explain that one more time?
Yes. This is the given information A and B only. And we need to find the equation of line L. Using A and B, we can find C by using midpoint. First point. Secondly, using A and B, I can find the gradient of AB and call it M1. And because it is given they are perpendicular, so using the formula M1 times M2 is equal to -1, I can find the gradient of line L, which is M2. Now I have the point C, I have the gradient, so I can find the equation of line L. Clear?
Yes, sir.
Okay.
In short words, this is the perpendicular bisector of AB. Now the question says find the perpendicular bisector of line segment joining these points. So it is a mixture of chapter 2 and chapter 5. You have to revise 2.2 because that was the first chapter. So almost 4 weeks, 3 to 4 weeks ago. We just did the chapter 5. You won't need to revise it. Find the perpendicular bisector. I am solving this question. So I need the gradient and the midpoint. First, I'm going for gradient. Gradient is y2 minus y1 over x2 minus x1. So 2 minus 8 is -6 and 7, 5 is 12. So this is -1/2. I have M1. Is my M2 positive 2? Do we agree?
Yeah.
So I have the gradient for perpendicular bisector. Now I need the point where it passes through. Perpendicular bisector. Using the word perpendicular, I have the gradient. Bisector would mean midpoint. So going for midpoint. x1 plus x2 over 2. y1 plus y2 over 2. 7 minus 5 is 2/2, 1. 8 plus 2 is 10/2, 5. So now I have the gradient. I have the point. Equation y equals mx plus c. Y is 5, m is 2, x is 1. Solving for c, that is 3. So the equation is y is equals to 2x plus 3. Find the perpendicular bisector of line segment joining each pair of points. For question number 1, the equation of perpendicular bisector is y is equals to 2x plus 3. Any confusion? This is
No, sir.
still the
No.
revision. There's nothing new. There's nothing new. This is still the revision. Now this is equation of circle. Before we start this, this is mandatory that we have a strong grip on completing square form and coordinate geometry. So 2.2 is the revision task, and chapter 5 we just did that, so I'm not worried about that. Now just have a look at this. X minus a whole square plus y minus b whole square. This is actually two completing square forms in one equation. Suppose this would have been written like this: plus something and then y minus b whole square plus something. Does it look like two completing square forms?
Yes.
So we need to have a strong grip on this. Okay, then we'll solve for circles. From my side, this is your task 2.2 only. For yourself, if you feel that you lack any concept from chapter 1 till chapter 6, page 116, you are more than welcome to revise and ask. Okay.
Okay, sir.
Exercise 2.2 minimum. Other than that, till page 116, anything if you feel that you still need practice or you need revision, you're more than welcome. We'll clear that first because our next topics strongly rely on the prerequisites. This is for today. Is there anything you like to ask?
I don't have any questions.
No, sir, no question.
Thank you so much. Oh, yeah, yes, back. Take care.
Lots.
Allah Hafiz.